Hello guys, and welcome to this first video in the series of land cover classification using machine learning. I understand that a lot of people find it difficult to generate training data set for their models, for training their models. So I thought I'll create series of videos that show how to do these from scratch. I've created a new GitHub repository. I'll put this link in the description of the video. So the first part is downloading any data, satellite data, Sentinel-2, Landsat from Google Earth Engine. I'll demonstrate it on Landsat 8. So you just have to click on this link and open in a new tab. By the way, Earth Engine has different types of Landsat 8 products: surface reflectance, top of atmosphere, raw images, and so on. For now, we are using surface reflectance, but feel free to use whatever you want to. And when you click on a particular product, you will see this link. Let's say T1SR is what we are using in this script today. So I'll take you through each line of code one by one and show what it does so that you can modify based on your requirements. So first we pull the image collection, T1 surface reflectance. Then I'm filtering it for dates from March to May 2021. Then I'm filtering it to the bounds of my area of interest, which is geometry. You can see here that in imports there is a geometry. By default this is for Bangalore here. So what you have to do is you delete this geometry and you create a new geometry of your choice. How will you do that? You click on this rectangle, okay, and then drag and create a AOI. You can uncheck this so that it's not visible here. So a geometry will be created, and that's the place for which your scenes will be filtered. Now I apply a cloud filter of 10%. You can tweak this as well depending on your area of interest. Then I create a composite using median. There are other ways also. You can do mean, you can do mosaic, but to get rid of clouds I do median usually. And then you clip the scene by your geometry. So you can tweak any of these as per your requirement. Now moving on to adding the layer. So you add this composite image. You display bands 5, 4 and 3, minimum maximum set, and so on. And then remaining code piece for exporting it to the drive. So now I'll run it. It should produce an image for my area of interest, the AOI that I just prepared. Okay, so here is our Landsat 8 layer. Now about exporting this image, we are exporting bands 1 to 7. Why 1 to 7? Because when you go to the description of Landsat 8 at USGS, you can easily Google and find this page. I'm taking all the bands that are 30-meter resolution all the way up to band 7 SWIR2. Obviously you can take other bands also, but this is something for a demonstration. I don't feel the need to do that, so we are only proceeding with bands 1 to 7. Then you description is basically the file name and what you will what it displays in the task. Folder is the drive folder where it will go. Scale is the pixel size that you want. Region, if you let's say want it to for a smaller AOI, but because you have already clipped it, so it doesn't matter. File dimension, you can keep this. This is basically when you are doing it for large areas, what is the largest row or column size. Maximum pixels also, the default is pretty low, so when you export your image for large area it will throw an error, so I've kept this by default. CRS is basically the projection. I know that for my area it's 32643, which is UTM-43N. If you want, you can also comment out this line or simply remove it and it should work just fine. I'm keeping it. Now when you go to tasks, you see this export to drive task. You run it, keep everything default or change if you want to, and it will go to my drive and then I'll run. Okay, so our task is now complete in roughly a minute. So when you go to your drive and go to this folder, you will see a Landsat 8 scene which is already there. You can right click and download. So now that the download has completed, I'll open this image in QGIS. Hope you guys are familiar with QGIS. So when I add this image, I go to properties, I can change bands, see number of bands, all these 7 bands that we exported. I'll do 543, and that's how it is, the FCC image that you usually see. The other thing is that you see this line is not straight. This is because the data on Earth Engine by default was in a global projection system, but while exporting, I forced it to 32643. So usually I remove and then export it. So when you do that way, your image will be straight, and that's what I recommend. I did it this way so that I can show you what the caveat is. Okay, that's it for the video. In the next video, we'll see how to generate a land cover out of this in QGIS manually. Thanks for watching this video.